Greetings, I'm Dev the developer.
And I'm Glitch, ready to turn your rigid, boring code into something with a bit more zap.
Today, we're opening a door that changes how you think about code. You've been passing values into methods since the beginning. Numbers, strings, lists. Today, you find out you can pass the method itself, behavior as a value. The idea is what this lesson is entirely about. Let's start with a problem. Glitch, I need you to write three methods. One that doubles every number in a list, one that squares them, and one that adds 10 to each.
3 methods, 3 for each loops. I feel like I'm reliving Groundhog Day, Dev. Each one changes exactly one character of the math expression. It's repetitive, it's redundant, and it's redundant, and it's redundant, and it's redundant.
It is wrong. Count the lines that are identical across all three. The method signature, the loop, the print call, only the math operation changes. Everything else is duplicated.
It's a violation of the dry principle, and if I want a fourth one, I have to type the whole thing again. What if I could just pass the math part in as an argument, like a recipe for a single ingredient?
That's exactly where we're going. But before we get there, think about what type that argument would have to be. You've passed in ints, strings, lists. This time, you're passing in a block of logic, a method. What type do you give a method?
A type for a method, it's like asking what's the flavor of blue. It's not a value, it's an action. It needs to describe the input and the return.
In C#, that's called a delegate. A delegate is a type that describes a method signature, its parameter types, and its return type. A delegate variable can hold any method that matches that shape. C# gives us 2 built-in families that cover almost every case.
Action and Func sounds like a low-budget superhero duo. What do they actually do?
Action and Func. Action is for methods that return nothing, void returning. Func is for methods that return a value. Let's do action first. The simplest one takes no parameters at all.
Action with no type parameters, empty parentheses, fat arrow, then the code. It's like I'm pointing at the logic and saying, do that later. Then I call it like a regular method.
Right. Those empty parentheses on the left side of the fat arrow mean no parameters. The fat arrow separates the parameter list from the body, and because the body is a single expression, there are no curly braces and no return keyword needed.
So the fat arrow is the delivery man for the logic. Everything to the right is the payload.
Yes, that's the body of the method. Everything to the right of the fat arrow is what executes when you call it. When the body is just one expression, you write it right there in line. No braces, no return. That form is called an expression lambda.
And if I needed to actually take an input, like tell me who to greet before I zap them with kindness,
that's action. The type parameter tells action what the one parameter will be, and add that parameter name on the left side of the fat arrow. No parentheses needed when there's exactly one parameter.
Action less than string, the parameter is s, fat arrow, then shout it out in uppercase. One parameter, no parens needed, it's concise, I like it.
Hello from the first call, and hello all caps from the second. Both are void returning delegates. Action is always the same rule. Does something, returns nothing.
Okay, so action is the void one. What about func, the one that actually brings back a trophy?
Func's rule is simple. However many type parameters you write, the last one is always the return type. Func takes an int, returns an int. The second one is what comes back.
3 delegates, double it, square, and shout. Each one is a single expression after the fat arrow. No braces, no return keyword, just the pure, concentrated logic. It's like a no-capes rule for code, efficient and streamlined.
10, 16, hello? The compiler figured out the type of X and name automatically. Because the delegate type says func int, comma, int, the compiler knows that X is an int. You never have to write the type on the left side of the fat arrow.
Type inference, so the lambda is basically a mind reader. It knows what I'm thinking because the variable told it. That's spooky, dev, spooky but useful.
Exactly. That's type inference. The delegates declaration carries enough information that the compiler can fill in the rest. Now, what if you need 2 parameters?
2 parameters? Do we just keep piling them into the angle brackets, like a clown car of types?
Yes, and remember the rule. The last type is the return type. So func less than int, comma, int greater than means 2 int inputs and 1 int output. On the lambda side, when you have multiple parameters, you have to write them in parentheses.
Add takes 2 ints and returns an int, parentheses required, then getGreeting takes nothing but returns a string. Empty parens needed there, it's all very orderly, almost suspicious.
Exactly. And good morning. The parentheses rule. Single parameter, you can skip them. Multiple parameters, you need them. No parameters, you need them also. When in doubt, just always write parentheses.
When in doubt, parent it out. Got it. But what's the point of a func that takes no input? Is it just for generating random chaos?
Timestamps, configuration, computed defaults, anytime you want to defer a decision. When do I compute this? When you call me, not when the variable is declared.
Deferred logic, I'll tell you the time when I feel like it. Clever. Now, what if one line isn't enough? What if my logic is too big for an expression lambda?
Then you use a block-bodied lambda, curly braces around the body, and an explicit return statement. Same as a regular method body. Let's say you want a lambda that describes a number, negative, 0, or positive.
Braces, explicit returns, it's like a real method just shoved into a variable. It's a method in disguise. Autobots roll out, or logic execute.
Negative, 0, positive. That's a block-bodied form. Use the expression form when the body is a single expression. Use the block form when you need multiple statements, local variables, or conditional logic. You cannot mix them.
No mixing. Either you're lean and mean, or you're wearing the full suit of armor. I can respect that level of commitment.
Correct. Now, let's get back to your original problem. Those 3 nearly identical methods. The fix is one method that accepts the transformation as a parameter.
One method to rule them all, and in the darkness, loop through them. I write one apply to all that takes a func, and the caller provides the math.
Write it.
Apply to all takes the list and the transform delegate, then I call it 3 times with 3 different lambdas. I've successfully deleted the boilerplate. I'm basically a digital Marie Kondo. This code now sparks joy.
Before we run it, that's the key insight right there. Apply to all does not know or care that it's doubling or squaring or adding 10. It just knows that it has a transformation to apply. The caller decides what that transformation is.
Separation of concerns. The method owns the how and the caller owns the what. It's beautiful, dev, like a well-oiled machine or a very efficient robot uprising.
Three sections, doubled, squared, plus 10. One method, 3 behaviors, no duplication. This pattern is exactly how the link methods work that you'll see in the next lesson. They accept a lambda and apply it. You've been one step away from understanding all of this since the beginning.
Wait, so link is just a collection of methods that take delegates? That's the big secret. It's like finding out the Wizard of Oz is just a guy behind a curtain using func of t, bool.
Exactly that. Link is built on this idea. Every method in link that takes a lambda is doing some version of what apply to all does. You'll see it more clearly next lesson, but now there's one more thing to understand about lambdas, and it's the part that trips people up.
Trips people up? Why do you always sound like a sinister DM before a boss fight? What's next?
Closures. When a lambda references a variable from the surrounding code, it captures that variable. Not a copy of the value, the actual variable. If the variable changes, the lambda sees the new value.
Wait, so the lambda has a memory of where it came from? It's like a ghost that haunts the scope it was born in.
Yes. Write the threshold example. Set the threshold variable, write a lambda that checks whether a number is above it. Run it, then change the threshold and run the same lambda again.
Threshold is 10, the lambda is born, it checks 15 against 10. True, then I change the threshold to 20. If the lambda is a ghost, it should see the new value.
True, then false. The lambda did not take a snapshot of threshold when it was created. It holds a reference to the variable itself. Whatever the threshold is right now is what the lambda sees when it runs.
A live connection, the lambda is basically a stalker for the local variables. It keeps them alive in memory even after the method should have ended. That's power, immense, terrifying power.
That's a very thorough way of putting it.
I mean for data integrity, obviously, not for clandestine data harvesting.
Obviously. The practical version. When you write a link filter that checks a local variable, like n greater than min year, where min year is declared above, the lambda sees whatever min year is at call time. That's closures doing exactly what they should.
Got it? Closures are the ghosts of variables past. Now, before we wrap this up, what can go wrong? I want to see the cracks in the armor.
Good instinct. There are 3 mistakes that come up every single time someone first writes lambdas. Let's go through all of them so you can recognize them when you see them.
I'm ready. My keyboard is poised for disaster. Good 1 is the minimalist version. No braces, no return. Good 2 is the formal version. Curly braces, explicit return. The mistake is trying to put a return keyword where it doesn't belong. It's like wearing a tuxedo with swim trunks. Just don't do it.
Either drop the return keyword in expression form or switch to block form with curly braces where return is required. One or the other, not both, and not neither.
Clear as crystal. Mistake number 2. Parentheses for 2 or more parameters, they are not optional. Without them, the compiler just stares at the comma like it's an alien artifact. If there's more than one, wrap them up.
Skipping the parentheses only works for exactly one parameter. 2 or more, they are mandatory, no exceptions. Now, the third one you can actually run because it's not a syntax error, it just produces the wrong output.
A logic error, the most devious kind. I'm not crashing, I'm just lying to you. Tell me more.
Write it and run it.
Line 3, console.writeLine of doublet, no parens. Then line 5, doublet of 5. The compiler is happy, but what's it going to say?
Look at the first line of output. That's not a number. That's the string representation of the delegate itself. The second line is 10 because doublet 5 actually ran. Storing a lambda and calling a lambda are 2 different operations. The parentheses are what makes it execute.
It's the difference between having a phone and actually making a call. Without the parens, you're just looking at the device. With them, you're actually talking.
That's a good way to hold on to it. The delegate variable stores the behavior. The call with parentheses runs it. Every lambda you write will follow those two steps. Assign, then invoke.
Got it? Action is void, func is return. The last param is the prize. Expression lambdas for the quick wins, block lambdas for the heavy lifting. Parens for multiple params, and closures are variable ghosts.
All of that is exactly right. You'll see every piece of it again the moment we move into link. Every link method that accepts a lambda is doing some version of what apply to all does. When you filter a list with a lambda that checks a captured variable, that is a func with a closure. You already know what every part of that means now.
The veil is lifted, it's not magic, it's just behavior being passed around like a hot potato. Once you see the pattern, the complexity just evaporates.
Now go write it. Define the method with a func parameter, pass lambdas in line. Try a block-bodied one. Change a captured variable and watch the lambda react. The concepts stick when they live in the code you wrote yourself. Don't just watch it, do it.